Welcome to another episode of Explained by AI. Ever feel like wrangling Python code in Databricks is, well, more complicated than it needs to be? Like
Yeah.
you're constantly copying and pasting the same utility functions or, dealing with different library versions across notebooks.
Yeah, that gets messy fast.
Well, today we're diving deep into Databricks Python wheels. These are kind of a game changer for managing your Python code.
Definitely. They help build more robust data pipelines.
Think of it as leveling up your Databricks engineering skills significantly.
Exactly. And if you're maybe a junior Databricks engineer listening, understanding wheels is going to streamline your workflow, like in ways you might not even realize yet.
Okay, so what is a Python wheel at its core?
Right. So basically, it's a .wesh file. It's a standardized pre-built package format for Python projects. PP 427 actually defines it.
Pre-built being the key word.
Absolutely. That's the main advantage over, say, source distributions like .tar.gz files. Because it's pre-built, it contains all the code and metadata needed, and it installs much faster. No compilation step needed on the target machine.
Right, like getting the fully assembled Lego model, not the box of bricks.
Exactly that. You can start building, or rather using the library, much faster.
Okay, so speed, convenience. How does this specifically help within the Databricks environment?
Well, in Azure Databricks, these wheels become your central tool. You use them to manage, install, and importantly, share your custom Python libraries.
Across the whole workspace. Clusters.
Yep, across workspaces and clusters. Say you write some great helper functions for data cleaning.
Instead of pasting them everywhere.
Exactly. You bundle them into a wheel. Databricks supports this natively in a few ways. You've got cluster libraries, which you install directly onto a specific cluster.
Okay.
Then there are workspace libraries. You store those centrally in the workspace, and multiple clusters can use them.
More reusable then.
Definitely. And finally, you can link specific wheels as job dependencies, so a scheduled job gets exactly the code version it needs. Nothing more, nothing less.
That sounds much cleaner. So when is it really time to say, okay, I need to start using wheels? What are the triggers?
Good question. I'd say if you find yourself writing and reusing significant amounts of Python code helper functions, custom classes, complex logic, that's a big sign.
Stop the copy-pasting madness.
Precisely. Wheels promote reuse and stop that code duplication headache. Another key time is when you want proper versioning and maintenance for your code outside of notebooks. It brings better organization.
Makes sense. Version control for your utilities.
And if your team uses CI/CD pipelines for automation, wheels are pretty much the standard for consistent, efficient updates. You build the wheel, deploy the wheel.
Right.
Oh, and finally, controlling dependencies. By packaging your code with its specific required library versions, you avoid those "it worked on my machine" nightmares. You control the environment better.
Okay, I'm sold. Better organization, reuse, automation, dependency control. So how do we actually make one? What's the process?
It starts with structuring your project properly, like organizing your kitchen before cooking.
Right. Folders and files.
Yeah. A standard Python package layout, you'll have a main project folder. Inside that, a crucial setup.py file that's like the recipe.
Okay.
A readub.md is good practice, explaining what it does. Maybe a requirements.txt for external stuff, although dependencies often go in setup.py too.
And the actual Python code.
That goes in a subfolder, usually named after your package, like my package. Inside that, you need an init.py file. Could be empty, but it marks it as a package.
Right.
And then your Python module files, like utils.py or whatever.
So modularity is key here.
Absolutely. Break things down. Use snake case for module file names. Maybe camel case for classes inside them. Makes imports cleaner. A good init.py can also simplify imports later on.
Got the structure. Now that setup.py file, the recipe, what goes in there?
It's the core build instruction file. You use the setup tools library. So you import setup and find packages.
Find packages. Does what it sounds like.
Pretty much. It automatically discovers all the package folders, like your My package, so you don't have to list them manually. Then you call the setup function.
Okay.
You give it metadata, the package name, a version number, super important, and tell it which packages to include using packages.
And the dependencies, like if my code uses pandas.
You list those, and the install requires argument. It's a list of strings, like pandas 1.5, 2.0, numpy.
Specific versions, right. Got it.
Once that setup.py is ready, you go to your terminal in that main project directory and run Python setup.py bdist wheel.
Bdist wheel.
Yep. That command builds your wheel, serol, double day ochel. You'll find it inside a new dist folder.
Simple enough.
Although, a slightly cleaner, more modern way is to use the build package. You pip install build, then just run python-m build. Same result, often cleaner output.
Good tip. What about .gitignore?
Ah, yes. Definitely add dist build, maybe .eggs and .egg info to your .gitignore. These are build artifacts. You don't want them in your Git history.
Okay, makes sense. We've built our shiny .hl file. How do we get it into Databricks to actually use it?
Several ways, depending on what you need. The simplest, maybe for trying things out, is a manual upload directly to a cluster.
How?
In the Databricks UI, find your cluster, go to the Libraries tab, click Install New, choose Upload, and just pick your .ho,
And then?
and then it's installed in that cluster. Any notebook running on it can just import mypackage.utils as utils, or whatever your structure is.
Easy for testing? But what if I need it on multiple clusters, or for automated jobs, less manual effort?
Right. For that, you typically use either DBFS, the Databricks file system, or workspace libraries.
Okay, DBFS first.
You upload the wheel to a location on DDFS. You can use the Databricks CLI for this, something like Databricks FSCP your wheel.ddhl, dbfs.libraries, or just drag and drop in the UI.
And install it from there.
Yeah, from within a notebook on a cluster, you can use a magic command. %pip install dbf's library your wheel.ahl. It pulls it from DDFS onto that specific cluster session.
Okay, %pip install and workspace libraries.
That's often a bit cleaner for managing shared libraries. You upload the wheel via the data section in the UI. Under libraries, creating a workspace library, it's stored centrally.
So it's not tied to DBFS paths.
Exactly. Then you can attach this workspace library to any cluster through the cluster's configuration settings in the UI. Or, again, use %pip install, but with a workspace library path, which looks a bit different, like dbs.workspace libraries.
Seems more organized for shared stuff. What about full automation like CI/CD?
That's the gold standard for production. Your CI/CD pipeline, think Azure DevOps, GitHub Actions, Jenkins, whatever handles it.
Oh.
The pipeline automatically builds the wheel after code commits, runs tests, then uploads the .artifact to DBFS, or maybe, preferably, updates the workspace library.
And installation.
As a final step, the pipeline can call the Databricks REST API to tell specific clusters to install or update that library. Fully automated, very reliable.
This is all clicking into place. Now let's talk pitfalls. What are the absolute crucial best practices we need to follow when using wheels in Databricks?
Okay, yeah, best practices are key. First off, versioning. Use semantic versioning major.minor.patch. Be consistent.
Like 1.0, 1.1.0, 1.1.1, etc.
Exactly. It clearly signals the type of changes. And define that version number in one single place, either setup.py or maybe a version.py file that setup.py reads from. Don't scatter it.
Keep it DRY. Don't repeat yourself. Got it. What about those dependencies we listed in install requires?
Super important. Manage them carefully. Only include what you absolutely need. Make sure those libraries are compatible with your Databricks runtime version.
Ah, compatibility. Good point.
And pin the versions. Don't just say pandas. Say pandas 1.5000 2.r or even pandas 1.5.3. This prevents unexpected breakages when a dependency releases a new version.
Avoids nasty surprises. Keep the wheels lean too, I guess.
Definitely. Avoid heavy packages unless truly necessary. Smaller wheels install faster and have fewer potential conflicts.
Okay. Testing. You mentioned testing earlier.
Essential. Non-negotiable,
Yeah.
really. Write unit tests. Use a framework like PyTest. Put them in a test directory.
And run them.
Run them before you build the wheel, always. Locally and in your CI/CD pipeline. Catch bugs early.
Makes total sense. CI/CD seems like a best practice in itself here.
It really is. Automate the build, test, deploy cycle. Keep build artifacts, meaning old versions of your wheel, so you can roll back easily if a new version causes problems. Artifact retention is key.
Rollbacks, yeah, important. What about how we install on clusters? Cluster library versus job dependency.
Choose based on use. If a cluster is long-running, maybe used for interactive work in multiple jobs, installing as a cluster library via UI or API makes sense. It's always there.
But for specific tasks?
For jobs running on dedicated or ephemeral clusters, using the Databricks Jobs API to specify the wheel as a job dependency is often better. The library is installed only for that job run. More isolation.
Granular control. Okay. Documentation.
Don't skip it. Your reame.md should explain what the package is, how to install it, how to use basic functions, and list its dependencies.
And inside the code?
Docstrings. Explain your functions, your classes, their parameters, what they return. It helps everyone, including future you.
Future me always appreciates that. Any other final best practices?
Yeah, a couple more quick ones. Security. Never, ever hard-code secrets or credentials in your source code. Use Databricks secrets or environment variables. Consider security scanning tools in your pipeline.
Good point.
Wheel size. Keep them small.
Mm.
Under 100 millibeats, a good target if possible. Exclude things like test data or docs from the final wheel using manifest files or similar techniques.
Okay.
And naming conventions. Be consistent. Snake case for modules, variables. Camel case for classes. Readability matters.
This has been incredibly thorough, really helpful. As people get more comfortable, are there more advanced things they might run into?
Sure. As you grow, you might use Databricks repos integration. You can actually generate wheels directly from your Git repo within Databricks, which is pretty neat for ML workflows, for example.
Streamlines it further.
Exactly. And if your code base gets really big, you'll naturally start organizing it into sub-packages within your main package for better structure. Think mypackage.data, mypackage.models, etc.
Multi-file libraries, yeah.
And keep an eye on Unity Catalog. While it's still evolving for libraries, the vision is for much better governance, sharing, and access control for assets like wheels across the entire platform.
So lots of potential there. It really sounds like wheels are fundamental for, well, professional Python development in Databricks.
That's the bottom line. Mastering them moves you beyond just scripting in notebooks. It's about building scalable, maintainable, reliable data solutions.
Using best practices avoids so many headaches down the line.
Absolutely. Dependency conflicts, code inconsistencies, deployment issues, wheels done right, help manage all of that. It's a much more robust way to work, especially in a team.
Definitely gives us a lot to think about for structuring our own code better.
Yeah, consider how you can take some of your reusable Python logic right now and start packaging it up. It'll likely improve your current project straight away.
Do you have any topic that you would like to have explained? Drop it in the comments.